topic of thin cylinders and thick cylinders. So we have our beautiful students here to explain what is a cylinder and how stress and strain are calculated.
The pressure is here a closed container, fuel.
Okay. Good morning all. Today we are here to discuss a small topic for a DT video. I hope I have a solid model in my hand. Do you know what is this? Cylinder, right? So this cylinder is being studied from our 6th standard. Do you know what is the volume of the cylinder?
Volume, amount of space it can hold.
Amount of space, exactly. Amount of space it can hold. Whether it is internally or externally. Internally, right? So what we are going to store in this cylinder?
Yes.
Gas. So what is the application, or can you tell what are the different types of cylinder we have?
Thin cylinder and thick cylinder. Thin cylinder is thickness is very small. Thick cylinder is thickness is very large. Thin cylinder is T less than 1/15
Of diameter.
of diameter. Compare of thin cylinder, T greater than 1/15 diameter.
Okay.
The applications like thin cylinder is boiler shields and water pipes. And thin cylinder applications like hydraulic pressures and high cylinders.
Okay. So exactly what the explanation given for thickness of the cylinder with respect to diameter, T less than 1/15 we have we call it as thin cylinder, and T greater than 1/15 of its diameter, that is internal diameter, we call it as thick cylinder. And how these cylinders can fail?
So there's two stress act on the cylinder, sir. First stress is hoop stress, which is also known as circumferential stress.
Yes.
So it acts along the length of the cylinder, and also it fails the cylinder along its circumference.
Okay.
So the formula of this hoop stress is sigma h is equal to PD by 2P. In this formula, the P stands for internal pressure, and D is the diameter of the cylinder, T is the thickness. Coming to the other stress act on the cylinder is longitudinal stress, also known as axial stress, which acts along the circumference of this cylinder, and also it may cracks the cylinder into along its cross section.
So why you want to study exactly this stress on this particular cylinder is? So now you have come across this Iran Iraq war, and you have seen many ships going from this Strait of Hormuz, right? So all the ships carry a particular shaped vessel, that is dome-shaped vessel, and to transport this cylinder from one point to another point of the natural gas, so we have to store highly compressed gas inside this. So when we store highly compressed gas inside this, the walls are tend, and the walls of the cylinder will be tend to excessive pressure. So you imagine that you have seen so many explosions of LPG in homes. So it will be a disastrous one. So certainly we have to study the stress and strain and see the material is designed properly for the particular two types of stress. And can you tell something on this part?
So in a ship there is this types of cylinders to store the fuel gas. Nowadays the cylinders demand source also in India due to the costs.
Okay, exactly. The demand of cylinders are becoming more. Coming to the mechanics of solids, this plays a major role in studying the hoop stress and the circumferential stress and the longitudinal stress. And we have certain formulas for change in diameter, change in length, and change in volume. Right, can you tell the volume of the cylinder formula?
V is equal to pi r square h.
Okay, pi r square h, what is your R represents?
R radius.
Radius, okay. H represents?
Height of the
In other terms, we have one more formula with respect to diameter. Volume equal to pi
by d square by 4 into h.
H, okay. Pi by 4 d square h is one other formula. We are going to see calculate the volume. Okay. So this is the major drawback of designing this cylinder. Right? We are going to have different kinds of internal pressures with different kinds of storage. Gaseous liquids will have different pressures, and solid materials which will project some different pressures we have. So that we have to carefully see the dimensions of the cylinder has been designed. So going to the thick cylinders, we have radial pressure as well as equation called the Lami's equation. I think we have discussed in the class. Right? One is radial pressure, another one is the stress related to the periphery of the thick cylinder. Okay, Lami's equation, with the help of boundary conditions, we are going to calculate the radial pressure, and we have a radial pressure diagram for this as well. Okay. So I hope you understand what the topic we have discussed today. So I will summarize in whole. So we have a shape called a cylindrical shape. It has an internal diameter or radius, and the height of the cylinder is represented by h. Okay. So this cylinder, when you are studying the stress, because the cylinder has to hold pressurized fluid inside, that can fail up to in two ways. One is longitudinal way, and the other one is circumferential way. Whenever it fails longitudinal way, we call it as circumferential stress, and whenever it fails circumferential way, we call it as longitudinal stress. By calculating the formula using sigma 1 equal to Pt by 2T and Pt by 4T, we will come to know the stress happening in the two ways. Okay. So then we go to classification of thin cylinders and thick cylinders. It is classified based on the thickness ratio with the diameter. When the D is less than 1/15 of the diameter, we call it as thin cylinder, and it is greater than 15, we call it as thick cylinder. Okay. So coming to the thick cylinders, we have again Lami's equation to calculate the radial pressure. I hope you all understood the concept of thin cylinders and thick cylinders. Thank you.